My name is Wei. I am the Director of Research and one of the instructor flight test engineers at the Air Force Test Pilot School right now. But we're going to talk to you about a project coming up that was executed back in late 2018 and then presented in early 2019. A little bit about me before we jump in. So, as I mentioned, I'm currently the Director of Research at the Air Force Test Pilot School. What does that mean? Well, we've managed a bunch of staff-led projects that we fly in partnership with many organizations. Some of you may have seen some of our recent work partnering with the DARPA ACE program using the X-62 Vista to do live dogfighting, including flying the Air Force around, getting nominated for the Collier Trophy. Just been a huge honor working on those kinds of projects. As part of that job, I also advise student test projects, which is the HAVFlex one we will be talking about in a couple of slides. But kind of our primary job here is to act as instructor flight test engineers. So common myth is a lot of people think that only test pilots will attend test pilot school, because it's in the name, but about half of our students are flight test engineers. So that's the piece that is not as public, it's not in the name, but are a critical piece of the pilot teaming up with other members of the test team to execute flight test. One of my other duties is to run the test safety program. So that's, I know you guys have come through and seen academics on test safety, crafting THAs, safety packages. That's a piece that is executed correctly. It's obviously very important with the kind of diverse flight testing that we do. One of my other fun roles is the self-declared president of the Backseat Club. And basically the goal there is to make sure that we never have an empty backseat in any of our airplanes. So as part of that is flying myself. I love to do that. I'll talk to you about that on a future slide, but also just making sure the rest of our staff are taken care of and get to pretty cool, unique flights and not waste those opportunities. This was a student flight test project that I'm going to tell you about, and one of my previous jobs was the test management program director, where I managed all of the student flight test projects, about 8 per year. And then additionally, I used to work for Sting in the Test Foundations branch, basically making sure that all of that curriculum is executed correctly. I'm not going to dive too much into my previous flight test assignments, but certainly just to tell you a little bit about my background and things that I've worked on. You'll see it's primarily fighters and bombers in the weapons and electronic warfare realm. And then I also used to work at the Edwards Aerospace's safety office, where I chaired SRBs for all the test projects that happened at the base, as well as working on future policy. As far as my own training, so I came to the Air Force as a civilian. I've been a civilian this entire time after UCLA, got my bachelor's there in aerospace engineering. Working for the Air Force, they sent me off to go get a master's, paid for it on a full ride scholarship at Stanford, where I got an Aero-Astro master's, primarily working and doing research in their GPS and satellite navigation lab. And then again, the Air Force sent me off to get more school and more training in a pretty cool and unique exchange opportunity. I got to go to the Navy's test pilot school and go through their program as a fixed wing flight test engineer. Anyways, I mentioned that I love to fly, so just a little bit about my flying background while this video plays in the background. This was one of my super early flights coming back to TPS, and I think it was like my second or third F-16 flight ever. You'll see a T-38 there in the background. So Test Pilot School flies primarily F-16, T-38s, and C-12s as our curriculum airplanes. But as part of our qualitative evaluation program, our capstone exchanges with other test units, and then just other good deals on the side, I've had the privilege of flying 60 different airplanes for about 450 hours. I always tell people I'll fly anything that's even remotely airworthy, and to be able to spread that experience across fixed wing. I've flown about 14 helicopters now, 5 gliders, 2 remotely piloted aircraft flying from the ground control station, and it's just been a blast. So I always have to stop myself and realize that I'm a civilian. I didn't join the Air Force. I didn't have to join and become active duty. And I've somehow found myself in this really privileged position to be able to fly cool missions like the one you're here. This mission is actually what they call dissimilar chase. So we have 2 aircraft, the F-16 and the T-38, with very different performance capabilities. But we have to make sure that we can fly primarily in a safety chase role, sometimes in a photo chase role to get the right angles for data collection. And I just happened to be in the right place at the right time, and there was an empty back seat while some other instructors were doing an upgrade on this ride, and I got to just go along and enjoy the view. Uh, this video I actually made because I was going to go talk to my kids, I think first grade class back then, so you'll see as we go inverted on one of these upcoming maneuvers, I just wanted to give them a little wave like I did on that intro slide to you guys. So I really do enjoy being able to speak to other organizations, to all age groups and all backgrounds about the cool opportunities that Test Pilot School brings, and especially on the technical aspects to a group to be able to speak to you guys, because I know you understand airplane talk. And then I always like to just mention, like, I've done all that flying, and in the FA world, I don't even have a private pilot's license. So that's just a pretty cool, unique place that I found myself. All right, so we're here to talk about a flight test project that was executed at the Air Force Test Pilot School in the late 2018 timeframe, the results of which culminated in a paper and a presentation that we brought to the Institute of Navigation's Joint Navigation Conference back in July of 2019. The project was called codename HAVFlex. I'll tell you a little bit more about that. But I did want to lead off with the picture that's in the title slide here. This was, we've got a group of aviation photographers that are super passionate about just taking cool pictures of cool airplanes. And I saw this pop up on one of the Facebook groups I'm a part of, and they had taken the perfect picture of us doing a low-level test point through the mountains with the various systems under test, or SUTs. And I'll talk more about that on a future slide, but definitely kudos to a guy named Steve Dudreau for taking this picture and then agreeing to let us use it for future presentations. I also want to call out some of the members on the team, and I'll talk to you about them specifically later. So just an introduction to what a TMP, or a test management project, is. Basically, it's a real-world flight test program that's part of the USAF TPS curriculum. So I know in part of your previous academics, you've probably been taught about an acronym PAIR: Plan, Execute, Analyze, and Report. Imagine if we took all of those skills and all those phases of a flight test program, crammed them together into about an 8-month project. That's what our students are going through during the latter half of their flight test curriculum. The rest of the curriculum, the instructor knows the answer, and we're really evaluating the students on, did they go out, did they fly it correctly, did they take the data correctly, did they analyze it, and then did they find, for example, the correct piece of S of the T-38, even though we've done that every class for the last 25 years or so. TMPs are unique because as instructors, we don't know the right answer either, which is just like real world flight test. What we're here in an advisory role is to try to guide the students through planning, executing, analyzing, and reporting on whatever question that our customer or our partner has provided for us. So each year, or every class will do 4 of these, and we do 2 classes per year. So it's about 8 projects that are quite diverse and spread amongst various institutions. So the one we're talking about today is called HAVFlex. A lot of our student projects will use kind of the code name HAV with a word after it as a project. It comes from a little bit of aviation history from previous programs. We just kind of borrowed that naming convention. So I did want to give credit to the 6 students that were on the team because, as I mentioned, staff mainly work in an advisory role. So this is mostly their work. They're the ones who put together the test plan, flew the test cards, did most of the data analysis, and then the reporting. And the reason I got to do this was because none of the students could make the last Joint Nav conference, so I was the one that got to represent all of us, but definitely kudos to them and their work. So you can see we had 4 mainly fighter pilots on the team and 2 flight test engineers, including another civilian like myself who was going through TPS at the time. All right, let's talk about the motivation. I'm sure many of you who have had flight tests or even general aviation flight experience have noticed the proliferation of these low-cost GPS navigation devices. Circled there, you can see that it is interacting with an iPad mini. I fly with that on every one of my flights now. And then on the left, in the smaller circle, is a Stratus puck that helps to take in AFB, radar, navigation information, and then sends that to the iPad, primarily through ForeFlight. We'll talk a little bit about how we set up our test. But as we partner with different squadrons and flight agencies and then flying with them, I started seeing these devices everywhere. And along those lines, we started having conversations with other folks wondering, hey, I wonder how good these devices actually are in terms of accuracy and utility. We saw them everywhere. They were being issued as electronic flight bags back in that 2018 timeframe. We saw kind of headlines in the future that I'll take some snips on a future slide showing you where the Navy was officially using these because of an incident that they had. So the real question is how good, right? Good in quotes there. But what we mean by that is accuracy. And then a lot of these devices will report something called a figure of merit, which is how they think, how accurate they are. Well, how accurate is the figure of merit? And then we kind of restricted this down to low cost. And we use the words low cost to mean about $1,000. And that's what we would be paying if we were to try to compare them against kind of our high quality TISP is an acronym that we use that stands for time, space, position, information. And these are kind of bespoke systems that take a lot of work and a lot of post-processing to get to some of the accuracies that we're about to show. So depending on the aircraft that we flew on, we'll be comparing these low-cost systems to the very high-cost and very unique systems that basically are only available at Edwards and at other various test ranges. So finishing off the motivation here, we saw that the military, particularly the Navy at the time, back in 2018, was issuing Garmin watches to all of their aviators. And then the USAF decided to join along and said, let's give it to all of our specifically U2 pilots, which is kind of a unique platform. And then EFBs, electronic flight bags, were being used as far as putting checklists, but they also have for-flight and navigation capability. And then I'll highlight the kind of headline bottom of the slide here. There was this particular anecdote where a Growler crew lost their environmental control system, and it got so cold that it fogged over their canopy. They were completely essentially in IFR conditions at that time because they could not see outside, and then they had lost all of their instruments. And the anecdote here was that they used the Garmin watch. This one's an Apple, but a Garmin watch to basically navigate their way home so that they knew they could descend without worrying about running into terrain until they got low enough that the outside air was warm enough to defog their canopy. And by then they had gotten enough emergency communications to get back and then make an approach that was then guided by radar. So I'm sure you guys have been going through test planning academics where we use words like general test objectives, specific test objectives, and measures of performance or MOPS. So I'll kind of dive into what we did for this project. So the overall test objective for us was just to investigate accuracy and utility we kind of grouped these low-cost commercial GPS navigation systems. And as I already mentioned, low cost to us meant about $1,000, things that the average pilot or flight tester would be able to afford, and just to be able to buy and slap onto their either onto their aircraft or onto their wrist, or some of these are body worn. I'll tell you about those in a little bit. How we decomposed that down was we wanted to determine two things. First was just position and velocity accuracy. And like I mentioned on our previous slide, the way we were going to do that was by comparing them to our kind of state-of-the-art systems that are calibrated, post-processed down to a really good level, most of the time about 3 to 10 feet of accuracy. The next objective we wanted to look at was to characterize the utility of these self-reported figures of merit for these devices. So that it'll vary. On a future slide I'll show you. Some of them will give you a number, an estimated accuracy. Some of them just give you like a yellow or a red, but various ways that these devices report out how good they think are. And then finally, we wanted to get into these other two areas, which is evaluating utility. It's specifically for flight tests. So because most of our partners are in the flight test world, we were not looking at these for like, hey, Joe Pilot flying a Cessna around in using ForeFlight. This objective was specifically looking at flight test applications as a way to generate kind of cheap, quick and dirty TISP. And then finally, we wanted to go and demonstrate the utility of these low-cost systems for what we could define as contingency flight operations. And as you'll see later, we break that down into two kind of phases. One of them is just point-to-point navigation, And then the last of which is kind of the adverse weather recovery, which is the motivated by that incident with the Growler losing their ECS. We do want to highlight a little constraints. So as you can imagine, TPS's curriculum is jam-packed full of other stuff, and they're only with us for 48 weeks, and we're only able to carve out a 2-week fly window in that. So there's lots of things that we would love to be able to vary in our test conditions or go after more test points, but just because of that primary constraint, we were not able to get everything we wanted. So the 2 weeks really, from a GPS navigation standpoint, we'd love to vary DOP or dilution of precision in a more rigorous way where we predict where the satellites will be and we time our flights to do that. With our time constraint, we took what we got. So the DOP was what it was when we took off, and there was no attempt to vary that at all. And then because of their student timelines, we crammed so much into them, trying to figure out how to graduate within the 48 months while checking off all the other requirements. Their data analysis didn't get as in-depth as we would like. So for example, you'll see the results coming up in the future where they just take average position velocity results across this giant range of flight envelope. Airspeeds, anywhere from 150 to 1,000 knots of ground speed. And then altitudes anywhere from 5,000 feet MSL all the way up to 40,000 feet. They just kind of had to lump them all together instead of taking the time to really bin them and say, hey, is there an altitude effect here? Is there a ground speed effect here? Which we know from physics that there will be, but we did not get the chance to really dig down and break those out. So we want to caveat that while the results are definitely good, we stand behind them. Don't take this as a final answer for whether these things should be fully deployed across the DoD. This is more data that you can point back to that might inform future testing that can go on. And then I always like to pitch that, hey, TPS is always looking for cool partners with cool ideas that they want to fly, and I can be a good entry point in terms of bringing you to the right people if you have another idea that you want to partner with us. Speaking of what we tested, so we call them SUTs or systems under test. These are the 8 that we have. You can just kind of look by model numbers that this is a dated test, right? This is kind of the state-of-the-art commercial devices back in 2018. So depending on when you're watching this recording, it's been definitely several years. The Sentry device is still out there. The Stratus 2 and the 3 are kind of old. There's newer versions of them, but many people, because they don't want to drop another $1,000, are still flying the old devices. I used to wear this Garmin D2 watch on a daily basis, but it just got so old the battery life wasn't hanging anymore, so we got rid of that. But I keep them all around the school. Probably half the aviators that I fly with some version of a Garmin watch. The Pixel 3 and the iPhone 10s were the coolest iPhones and Pixels at the time, as well as the iPad Mini 4. There's obviously newer generations with different chips in them, but I think they're all still these L1 only commercial GPS devices. And then we found this other one called the Bad Elf Pro, and it was kind of nice because this one was you can turn it on, throw it in a flight suit pocket, and then just not worry about it. So it was very non-interference. We wanted to take a look at that one as well. As far as test aircraft, I mentioned to you that Air Force TPS primarily is F-16s, T-38s, and C-12s. So those are the ones that we had easy access to. And then depending on which aircraft we flew on, it changed which kind of TSP system. So if you go back and reference the slides, you'll see acronyms like ARDS or Gainer that have different accuracies associated with them. The bottom line here, those systems are way more accurate than the low-cost commercial devices that we tested. So we think we got a pretty good comparison, and we stand by those results. All right, so what did we do to get position and velocity accuracy? Well, we flew cruise conditions, so just kind of straight and level for a few minutes at a time. And we varied that from ground speeds of 150 to 1,000 knots based on wind and aircraft limits. So if you're not an aero person, well, this is where I'll remind you that GPS systems only care about ground speed. That is in terms of, how fast am I moving in lat-long altitude, but aircraft fly in airspeed. So don't get those two confused. We had to fly the aircraft from a safety standpoint in airspeed, but all of our systems were evaluated in ground speed. And then altitudes wise, Edwards Air Force Base is around 2,300 in MSL on a normal day. But so we couldn't go any lower than that. And also because the students were flying these by themselves in aircraft that they're not super familiar with, they have altitude limits above the ground. So most of our test altitudes are between 5 and 40,000 feet MSO, which conveniently covers a huge chunk of the flight envelope. Separate from that, we wanted to look at terrain masking. So if you have flown here at Edwards before or are familiar with the area, you may have heard of a Sidewinder low-level route. It's basically the most fun thing we do, just raging through the mountains. There's actual terrain higher than the aircraft on both sides of you as you kind of snake through the Kern River Valley. And we flew that at 500 feet above ground, and then airspeeds of 450 knots, up to 450 knots. And then when we looked at the years of merit and then the utility, we did ground test and then different flight test points that are common flight test techniques from other parts of the curriculum. And then the students took qualitative data there. And then we just did point-to-point navigation and then simulated instrument approaches. I'll show you a video later where we fly them on a clear day, but we pretend like, hey, would I mount these devices if it wasn't a clear day and I didn't have a good view of the runway? Let's get into some results here. So we compared them against our current TISP sources, and what you're seeing is that the accuracies are quite spread throughout the realm of good and bad. So just in terms of 2D radial error, you look at the top 4 devices there, it's not bad. You know, we're looking at like less than 100 feet, sometimes getting to a couple hundred feet there. And then what we saw later that we don't quite dive into in the presentation, but we found that because the bottom 3 devices, the Stratus and the Sentry, they actually take their onboard systems accuracy or navigation solution, send them to your iPad via Bluetooth, and then those are displayed in the ForeFlight app. And we were finding is that that was adding a time delay. And the reason we knew it was adding a time delay is because that position error scaled with the ground speed. So your same time delay is going to hurt you a lot more when you are moving across the ground at a much higher rate. So that was one of the key findings is we saw some of the devices that are generating onboard solutions and recording it right then and there had much better results than the unknown time delay that was injected by the Stratus and the Sentry and the way we set that up. And of course, all of those position errors will propagate into velocity errors because none of these devices are calculating velocity directly. They're just basically taking the difference between the 2 points over a certain period of time. All right, that's how it sums up. When we went, the previous slide was straight and level, just kind of trying to do more disciplined flight testing. Then out and we did a whole bunch of military flight maneuvers in terms of aileron rolls, loops, varying altitudes, steep turns, and then low level. And again, because of the students' time limitations, they kind of just bundle these devices together. What you're seeing though is really that like there was not a huge degradation. Yeah, it got worse, right? It went from 40 feet to 130 feet or 200 feet to 400 feet. But overall, these things didn't completely quit. They were able to track during these pretty aggressive maneuvers as long as we didn't stay inverted and point them away from the satellites for too long. But most of these maneuvers are on the order of a few seconds, and then we turn upright again. Or if we're flying towards terrain and we kind of terrain mask a certain amount of satellites that are low on the horizon, well, the next turn is to the opposite direction, and then we have access to those satellites again. So overall, not bad. So certainly the terrain piece was not a huge limiting factor. Figures of merit varied wildly. So, for example, we had iPhones and iPads that would just give you their estimate in feet as far as what it thought it was. And what we found is that the ones that gave you a number were wildly optimistic. So, like if you look at the bottom 3 on the top table there, the Stratus, the Sentry, they basically said they report them in meters at the time, but it was like 1 meter the whole time. And that's just basically mathematically impossible to get to with a commercial L1 only GPS system. So when we compared them to actual error, man, they were 2 orders of magnitude off. They were in actuality a few hundred feet off. And then some of the other devices that were, 10, 15 feet off were actually not bad. But since their Stratus devices and the Sentries are actually really popular out there, we wanted to make sure that we got the word out that the self-reported figure of merit is garbage and do not trust those. And then there's some other devices like the Garmin that just gave you a green or a yellow or a red, and really there's no definitions attached to those, so we did not think that those were useful at all. Because what does yellow tell me? Is it useful? Can I use it? Do I trust it? There was no information at all that came with that. For the utility for flight tests, like I mentioned, we captured qualitative, aircrew comments only, but we looked at things like how could we attach the airplanes? Was it easy to access the data in real time and monitor that it was working? What about battery life, right? So the aircraft that we flew on are pretty small airplanes. So even the longest duration one we had was a C-12, but they had no problem doing 3-hour flights. We have seen them used. One of the pictures I showed you earlier was from an MC-130 that can obviously fly for much more than 3 hours. And in those cases, we're seeing aircrew having to plug them into either onboard charging systems or bring batteries along, and that would come with some challenges as well. And then for flight test, the most important thing is that we can get the data afterwards. So we talked about what's the easiest way to do that. Most of the devices can talk to ForeFlight, and then you can just log your position in ForeFlight. As soon as you get back on the internet, you just email it to yourself. And it's super easy to do. The Pixel phone is an interesting use case because Google, the folks in their navigation lab actually made us a custom app to use when they found out we were doing this experiment. Unfortunately, these guys are not aircrew members. They're computer science majors. So they gave us this app that had so much data, but it was in tiny, tiny font and it scrolled through way too fast. And it's not something that we thought was useful in flight. It was very useful post-flight, but just an example of having to communicate with our partners and our customers about future use cases and how to design apps that are useful there. And then Garmin and Bad Elf, it was fine to download, but we just thought it was a little bit annoying to have to download yet another app on my phone and then learn a new interface there to be able to get the data on them. All right, let's get to contingency flight navigations. The easy one is point-to-point navigation. So all of these apps and interfaces have a way you can put in a set of coordinates and say, hey, give me guidance to fly to that coordinate. And there was no problem doing that, basically. So overall, aircrew thought this was a cool capability. So if you think back to that previous anecdote where they were completely thin, but they were still up pretty high in altitude, so they weren't worried about running into terrain, and their standby attitude indicators were still working, so they knew which way was up. They just needed to know which direction to fly back home. And that's what they did is they programmed their Garmin watch and said, hey, give me a vector back to the nearest airfield. And then they flew there. That part aircrew felt was a useful capability. The part that's not so useful, or actually that she wanted to put the warning out there, is in terms of attitude. So that's, which way is up, essentially, in our airplane. We saw, and I'll show you this video later, that in a pretty benign turn in the military world is a 2G 60-degree bank turn. You'll see the pitch axis of these devices, because they're really cheap kind of MEMS accelerometers and gyros, will vary wildly, even though in actuality we are flying a completely level turn across the sky. And then even on a pretty benign, like a glide path like you would be on flying an ILS or a TACAN approach, we saw pitch deviations plus or minus 5 days that can get pretty disorienting if you're completely fogged in the weather and that's your only attitude reference. One of the nuisances is just a way ForeFlight was designed, because it was not made to be flown. It was not made to allow for flying approaches. Was that we'd get these pop-ups that are useful but obscure things. So overall, the aircrew felt this was unsafe to use for adverse weather recovery, and one of them even went so far as to say, I would rather just punch out of the aircraft. So I'm going to show you this video here. I'm going to talk over it a little bit, but on the left you can see that's the T-38 HUD video. So obviously we can see the runway and we're flying. It's in safe conditions, but in a simulated approach, you can see that the pop-ups are obscuring the ForeFlight display, as well as the pitch attitude was not so good. So on that piece, navigating back to home field is fine. Any kind of precision flying, it is not okay for, and I'll show you that on the next video. So before I hit play on this, just to give you an orientation, the aircraft is in straight and level flight initially. We will bank to 60 degrees, and it's just 2 Gs in a level turn. And so if you look in the altitude piece on the top right of the video, that will stay roughly constant. But because attitude and then ground speed is calculated from position and attitude, you're going to see wild variations in pitch and in airspeed on the left side. So we haven't begun to turn yet. The aircraft will start to turn soon here. Remember, this is a level turn. The nose is on the horizon, and we're actually seeing that's up to positive 45-ish degrees of pitch. And then watch what happens next when it quote unquote recovers, and then wham, it goes completely down to where the attitude is pointing at the ground. Airspeed is varying wildly, even though this is a level, constant airspeed turn at 13,000 feet, 60 degrees of bank. So that's a little bit more aggressive than a typical Cessna would fly, but for military flying, that's a very benign maneuver. And we saw these very troubling results repeatedly throughout. So that wraps everything up, and I think there might be a time for Q&A with your instructor. I'm obviously not doing this live with you, but you have my contact information on the title slide, and feel free to reach out to me if you want to talk about this some more.